Ninth grade science class, I asked a question to the teacher. Says, well, when you strike a match, why does not the earth burn up? Well, the reason why the earth doesn't burn up is because the bulk of ambient air is composed of non-combustible gases, or gases that do not support the burning process, like nitrogen and your rare gases like argon. Okay? So because of this, the atmosphere doesn't burn up. Now, when we release the hydrogen and oxygen gases through the electrical polarization process under resonance, then we now automatically adjust the burn rate of hydrogen. I'll put it back up here again. The burn rate of hydrogen from 325 centimeters a second down to the burning levels of 43, 42, 41, and this would be gasoline, to gasoline or even to diesel fuel. And automatically, that when you release the hydrogen and oxygen from natural water, you're also releasing the non-combustible gases from water, and you're adjusting the flame down to around 47 centimeters a second. Now, when I was filing the patents in the United States and in the international areas, they didn't know what I was talking about. The prior art was styrmetrics. Styrmetrics basically was taking the hydrogen atom, go through an orifice, and the hydrogen would hit a hot plate, and then the hydrogen would intermix with the oxygen, and then that combustion with the energy going in the hot place now could release some of the energy in the hydrogen. The problem with that, the prior state-of-the-art technology, was that it took a tremendous amount of energy into the hot plate in order to come up with the gas combustion process. But inherently, when we release the gases from water, it adjusts around 47 centimeters a second, and when we light the gas, even to melt steel, it's a self-sustained system. And it blew their minds in the fact that we could really do this. And we went on further with it to give an illustration of it, because when they asked me, the United States is a very highly scientific country, right? So when they approached me and said, we don't know what you're talking about, adjusting the burn rate of hydrogen, I said, if I give you the answer, will you give me my patents? And of course I gave them the answer, and consequently received my patent. To give you an example of this, what I'm talking about is that if you would have a flash tube, that this would be a flash tube here, and you fill this flash tube up with hydrogen and ambient air gases, and you would spark it at one end, then the burn rate in 1 second would travel about 325 centimeters in measurement. Now, if I would fill the tube up with natural gas and ambient air, we found out that it would burn around 42 centimeters per second. So it became very obvious then that just as we could sustain and maintain the burn rate of the hydrogen and oxygen gas around 47 centimeters a second by using the non-combustible gas as a modulator. Now what I mean by here's the oxygen atoms, and now you subject it to a modulating gas, and this is the oxygen atom, as you see right here. And so as a result of this, that the modulated gas, or the non-combustible gas, as you see right here, slows down the speed by which the oxygen atom unites to the hydrogen atoms. And as a result of this, you now slow down the speed by which these two gases will go into combustion. So it's quite obvious that if we now would subject natural gas or take hydrogen, we now can inject more non-combustible gas in the process, and we can take it right down to the burning levels of natural gas or gasoline or diesel fuel.
So all you have to inject is air.
Right. So now we got a third component to the technology to comply with the law of economics. The only thing I'm using now is natural water, right? Voltage, which I'm not, is a non-consumable source of electronics, right? Now I'm using ambient air. Now if you guys, if anyone can come up with cheaper commodities than that, let me know and I'll go pat him on the back. Okay, so now that gives us the ability to use an ambient air in the process. Now when you look at an internal combustion engine as an example, then you, as a design engineer, you will look at the internal combustion engine in 3 ways. And as you see here, now when we feed this in, the gas coming in, get my little spark plug here, that when the gases go in, number one, the internal combustion engine is a mechanical drive device, is it not? Got us here today?
Yep.
Okay, secondly, is it not an air pump?
Yep.
Does it take the pump and sucks it into the carburetor?
Yep.
Right? And shoves it out the exhaust?
Yep.
Thirdly, is it not a manufacturer now of non-combustible gases? Yes, because as the ambient air goes in and mixes in the gas compression process, there's 2 things simultaneously. It consumes the oxygen atom and also consumes any burnable product in the air, so its byproduct is non-combustible gases. So it was very easy now to take the internal combustion engine, take the fuel cell over here, the water fuel cell technology, come up in here, meter mix it with the exhaust gases, and as a result of meter mixing it, now we can take it and pick it back up, and we now automatically adjust the burn rate of the hydrogen gas to co-equal gasoline and diesel fuel. Now since I'm using the ambient air up here, how much is it costing me? Zippo, right? So it takes and does it comply with EPA standards? Yes, because the non-combustible gases, the air going through the process does not interact with the process, so you're not changing the status quo. So when they talk about it's impossible to do something, it is only to the creative imagination of the technology. Okay, so now we take this technology, the non-combustible gases, is that we now can take hydrogen, we can take air and expose it to the flame to create non-combustible gases, and now we have a way of taking and transporting hydrogen gas through conventional gas grid systems without ever changing it. Now the prior art says that you have to take hydrogen gas, cool it down about 465 degrees below zero, you got to put it under a lot of pressure, and you got to truck it down the road. You spend a lot of energy to move the hydrogen down the road. But by simply meter mixing now, non-combustible gases from ambient air, you can adjust the burn rate of hydrogen less than that of your standard fossil fuels. And guess what? You don't even have to change even the control knobs on the distribution lines in order to get it transported. So all of this is still now compliant to the law of economics. So that was the number one major invention, was to be able to render hydrogen safer than that of natural gas. And of course the quenching circuit technology gave us the ability. Now another area that we developed to comply with the federal and the state safety code regulations is we developed what was also called the quenching circuit technology. And in all probability, if the NASA would have had this technology, our astronauts would not have died in vain. But to give you an example of this, as an example of this form of technology, I'll go like this. It is a requirement on the gas ignition that the hydrogen and the oxygen atom must unite together to bring on spark ignition, right? So we found out that the fuel cell is a multi-gas generator. It's producing and releasing the ambient air in the form of non-combustible gases in the process. So we found out that if we pass it through a very narrow passageway, somewhere along the line, the non-combustible gases are going to separate the hydrogen and oxygen gases and come up with a no spark zone. So as a result of this, we now had developed a 100% fail-safe way of igniting the gas and maintaining it with a 100% anti-spark back device, irregardless of gas volume or pressure. And the simple technique was to use the non-combustible gases to give us the quenching effect inside. Now the materials we use in the quenching disc and supporting the high temperature flame was for like ceramic material, like aluminum. The ceramic materials generally go up to around 3,000 degrees before they start getting real soft and melt down. But we can support flames anywhere from 2005 to 10 to 20,000 degrees and not melt the ceramic material, because the non-combustible gases not only prevent spark back into the system, but it also elevates and controls the speed by which the oxygen atom is now being released into the air under pressure. And as a result of this, the non-combustible gases acts as a cooling agent between the flame and the ceramic material, and it's actually cool to the touch. So that simple thing now gave us the abilities to comply with the federal highway safety code regulations. And of course that technology took us to the quenching tube, by which these small little passageways acts as the quenching element, and now you can pass the fuel through this quenching tube, and as a result you can shoot it with a tracer bullet or burn it with a lighter, and it will not spark back into the generator. That gave us the ability to retrofit now even to cars.
What size are those holes?
Right, well, there can be 15 to 25 thousandths. Okay, and if you want to mix it a little bit more, you now can add more non-combustible gases to it. So if you cycle more non-combustible gases with it, the holes can elongate even a little greater than that. Okay, so that gave us the abilities to retrofit the fuel cell to existing technology. But as we mentioned a little while back, now we have shown that voltage disassociates the water molecule. We show the circuitry, the abilities to restrict the amp level and allow voltage to take over, but we need to produce a lot of electrical power. Now, most of the electrical power plants are being propelled by coal or gas or what have you. We can use the water to do this. But there's cases now where we need higher energy yields. And so the EPG system was developed for this purpose. One is I was showing you with the the magnetized gas inside the closed loop tube. We're using various methods to propel the gas. Now, in this particular case, we were talking about the electric motor driving the non-magnetic turbine wheel, which could be converted to wind power and what have you. If I wanted more power output of this generator, what would I do? Could I put another pickup coil here?
Yep.
And could I put another pickup coil here? So power output of the generator is determined by what?
The amount of coils.
Right, it's determined by number one, the strength of the magnetic field, the velocity of that magnetic field, the number of turns per coil, and the number of coils, right? So all of these, do these not comply with the power factor of electrical power generation? The only thing I've done now is I have eliminated the opposing magnetic field problem, which was the greatest problem in electrical power generation. Now I'm a little tired of the non-magnetic tube, and so in some cases I now have put in an electromagnetic pump. And I come over here with an electronic pulsar, and I now want to produce an electrical generator that has no mechanical moving parts to it. Now in this analysis, if my eraser was a magnet, and I would put the magnet close to the magnetic gas, would it lock onto the gas? Right. Yes.
Yeah.
All right, now, so if I move the permanent magnet, would I now move the gas?
Yes.
Yeah.
So therefore, if I now take this coil and I energize this coil to produce an electromagnetic field, and I deflect this magnetic field in a vertical direction, would I not now move the gas?
Yep.
Where's the bearing?
There ain't one.
Where's contact brushes? Can I now either hook this up in series or parallel arrangement, come up with any power output I so desire?
Yeah.
Yep.
What about the geometry of that system? Can you not refine that so that you were describing this in terms of a square?
Oh yeah, sure.
Yeah, but that's not the geometry of it in real terms.
No. Geometry in real terms, it is now going circular in spiral configuration.
Right.
Were we talking about that last night?
Acceleration, right? Acceleration.
Yeah. Now, the key to it is, for an example, if I had the electromagnetic pump here, and now I had the magnetic tube like this
It
going around.
becomes a coil.
All right, now it comes the coil. Now, if let's take an analysis of this. Let's say that coming into this, this had a given magnetic field strength. Now, in electronics, if I would take a coil and I wrap this coil many turns, the more times I'd wrap it, the stronger the magnetic field would become, right? So if I had 1x magnetic field here, and I coiled this now, and let's say I coiled this 100 times, what's the magnetic field strength of this?
It becomes exponential.
All right, so therefore it's 100 times. All right, so I now start to wrap the coils around this circular pathway, this coil pathway, as you see here.
Coil on a coil.
Coil on a coil. Now my power output is determined by, again, the strength of the magnetic field, right? The velocity of the field. And what's my next equation? The number of wraps, right, of the coil, and the number of turns per coil.
That gives you a field strength.
It gives me tremendous field strength. Okay, so here I'm using now an electromagnetic pump to produce the electrical energy. Now, when you get to EMF fields, there's a reason why this was developed this way, is because the next question is, I want to eliminate as much as possible Lenz's laws. On opposite Lenz's laws, okay? So the prior state of the art says here I have a coil, and I'm now moving the magnetic field through this coil, and I'm now moving it perpendicular to the coil. So I have tremendous opposition in moving that magnetic field, as he was pointing out, right? Well, now, can I move a magnetic field inside another magnetic field?
Yes.
And could I do it in a way that minimizes the amount of opposition?
Coherent.
Absolutely.
Coherent.
Yeah, because under this analysis, the magnetic fields are moving perpendicular, so you have opposition. But if I moved it through this way, I have a minimum amount of opposition in the movement of the field, right? So when you develop an EMF field of a coil, which way does the EMF develop?
At right angles to that.
Yeah, it develops away from the coil. That's the EMF.
So you take it with the coil now.
Yeah, so now you got a situation that,
Well, you've changed the whole laws of the electronics.
well, but, am I defining the laws of physics?
No, you're not, of course not.
Yeah, okay. So here is the magnetic field of the gas. That's the gas, right? And this is the EMF field. So therefore, can I not pass this magnetic field through this magnetic field and have minimum amount of opposition,
Of course.
right? So when they say they cannot do it, it's the way you should look at it, the technology.
So we've developed technology that's produced that effect, but that
Yes.
effect need not necessarily be like that as you prove.
Yes. So therefore, I've eliminated or reduced Lenz's law down to minimum because I'm moving this magnetic field inside another magnetic field, which gives me least amount of opposition.
And you're still getting the same pickup in the coils, though.
Sure, absolutely. So
And the axis is a 0 point.
Right.
A theoretical
the
point.
the center of anything is negligible force.
Right,
There's a negligible force in the center.
theoretical axis.
Right. So the differential is from 0 on out. And so therefore we have the ability to move the magnetized gas with very little opposition to it. Now you link this up with a water fuel cell, and a water fuel cell now is producing the electrical energy. Can I not increase that electrical output still further?
You control it.
All right, now when you move the magnetic field through that alternator, that field moves at a very slow pace, very slow. So now can we increase the speed of the magnetic field? And can we not do it in a way that we can increase power output still further? So we've taken the technology now, even to a very higher state. We have now taken it to a point of solving the problem of over-unity devices by simply now injecting laser energy input into the magnetized gas. Now what I want to do is give an analysis here. Now let's say, for an example, this is exit. All right, now I want to increase power output still further, and I'm now starting to inject laser energy into the magnetized gas. Now the key was, how can we increase the magnetic field of mass, or increase the magnetic field without increasing mass? Now if you're doing that, you can do something. Now we talked about the coil wrapping, but another classic example is if I had the magnetized gas here, it's a phenomenal effect that if I would inject laser into the process, this electron would move out to a higher orbit, would it not?
Yeah.
Now in the law of physics, I better stop. In a mechanical drive system like the electromagnetic pump system to drive the magnetized gas, I pointed out in the development of the electromagnetic pump system that will drive the magnetic gas and all of its physical parameters in producing electrical energy very economically. Now, the question now comes, can we produce large amounts of electrical energy by moving the magnetic field even or close to that at the speed of light? Because the magnetic field moving through a rotary electrical generator is relatively very slow. Now, the key to higher power generations was in the areas that, like on over-unity devices, as we had mentioned, is that the prior art limitation was that to increase the permanent magnetic field, you had to increase mass, which meant you had to increase the energy input in to move the mass, so that inherently became a detriment to trying to produce electrical energy. So can we not now, for example, go ahead and then amplify the electromagnetic field of the mass without increasing the mass? And what we found out was that as you inject the laser energy, and the nucleus is absorbed in the magnetized gas nucleus, then this electron now will move out to a higher orbital state. And we know that under the law of physics that when you do this, something's got to happen, right?
It could be
And what-
anti-gravity, yes.
Yeah, yes. And one thing that takes place is that this electron, the electromagnetic field now, that holds it in its outer orbit becomes weak. And when this becomes weak, then for every action there's an equal and opposite reaction, then this electron starts to spin at a faster velocity. And under the electromagnetic theory of magnetism says that whenever a negative charged particle moves through an electric static field, B, its byproduct is electromagnetic energy. You know, there's four forces that affects the atoms. There's electrical force, electromagnetic, weak and strong nuclear forces. It's the electrical force that really is applied to difference of potentials that applies directly to the atomic structure of the atom, and then all the other ones are just built on top of that. So in reference to increasing the magnetic field strength, it was quite obvious that all we had to do was inject and allow laser energy to be absorbed by the atoms of the gas to now cause the electron to spin at a faster rate as it's now moving away from the nucleus. This gave us the ability to increase the magnetic field without increasing the mass. And that was the answer to over unity devices. Now, we're producing now, as we inject the laser energy into the EPG system, I've now converted the non-magnetic tube into a light guide. Light guide. Now, what that means is that I've now put in a reflective surface inside the non-magnetic tube. So now when I inject laser energy, a volt of laser energy into this system, and let's say, for example, this is a 10-watt laser, I'm now producing this magnetic field strength A. Now, as I do this, then this laser energy, would it not now start moving through this corridor, reflective corridor, close to around the speed of light? So as a result of this, now this laser energy is starting to move this field, this pulse field, and it starts moving and bouncing back and forth and closes this loop system and produces it at an extremely fast rate close to the speed of light. So if I want to increase more power output, in one example, as we pointed out in the prior art, I could add more coils to it, right? But now I want to increase tremendous amount of power. Let's say, for example, that I would take this non-magnetic tube, and I would take it from here to Auckland. How far away is that?
20 miles.
20 miles. And then I take the tube and loop it back here. And I wrap 1,000 turns per coil around this non-magnetic light guide. And I hook these coils in series parallel arrangement all the way to Auckland and back here. And I fill it up with a magnetized gas, and then at the one end I set a laser to it. Now if I take a laser and I strike the laser, how fast would the light energy go through the tube to back to here?
Speed of light.
And then faster than you can blink your eyes, right? Less than a nanosecond, right? All right, so now if I take a 10-watt laser and I laser and I produce this magnetic field strength, it would now move close to the speed of light to come back to here. Now, when I get back to this point right here, I now laser it again, and I strike the laser again, and now I have an intensity of the field equivalent to B size. And it now compounds itself and bounces around and gets back here again. I laser it the third time, and I produce a magnetic field 3 times in its intensity. Now imagine taking that laser, and I strike the laser 1,000 times, or let's say 1,000 times in a 10-watt laser. What would this magnetic field strength be equivalent to?
Gain exponential.
1,000 tons.
Yeah, so it'd be 1,000 times greater than, 1,000 times from the 10-watt laser. Okay, so I have what, a 10,000 or 100,000 watt laser equivalent of moving this gigantic magnetic field. So I'm now moving this magnetic field close to the speed of light. Now, the EMF field of the coil is only generated after the magnetic field goes through the coil wire, right? So as that bolt of laser energy is going through the gas, then there's very little resistance of this being moved through the coil, because as it's going down that coil, it sees an open corridor with very little resistance. Is that not so? So the EMF is only built afterwards. So if I would pulse this now and set this field and pulse it and hit it at this intensity, how much electrical energy do you think I can generate?
More than you ever want.
I can generate all the electrical energy for all the major cities.
So in other words, you've done
in
the
New Zealand.
equivalent of
Are
breaking
you
the song barrier, you grew from the EMF barrier.
Yeah, sure.
Are you saying that the laser will carry the gas around with it?
No. The gas remains stationary, and the laser action, in other words, the
expands
atoms.
and contracts.
Right.
Yeah.
And so, isn't that nice?
You streamlined the thing just like a hypersonic aircraft.
Right.
It's leaving the shock waves behind it.
Right.
You've got ahead of the shock waves.
Right.
No resistance. Absolutely no resistance.
Isn't that amazing?
I found him in.
Now you link this electrical power generator with the water fuel cell technology. What can you not do? The technology is only limited to the imagination for you to put it to work.
That on its own, just as is just phenomenal.
Yes, but you can't run the entire economy off of this
No.
power, because as I pointed out earlier, an electric motor cannot handle the workload of an internal combustion engine. And under the law of economics, we don't have time, for example, to change to electrical drive systems for cars. Detroit, for example, is not going to change their production line when Stan Meyer shows them how to take a $2.50 recycling tube, use the exhaust gases to adjust the burn rate of hydrogen gas to co-equal that of the fossil fuels, and run it off of water. So the law of economics dictates that this is the direction we'll go. But the evolution of its development will continue this because, as I was mentioning to several others during our break, that the main centralized power systems have turned out to be the wrong approach in order to provide power like in the United States. Because in the inter-period of time from the time the first power plant was developed, a lot of the copper wires or the electrical transmission lines are starting to crystallize. So we're starting to have breakdowns, the Brown effect occurring, or the electrical wires are now breaking down because of the high exposure of voltage, and they're crystallizing, and we don't have the copper to go ahead and replace those transmission lines, nor do we have the monies to be able to re-string the transmission lines. So one of the main philosophies now in the United States is to come up with a home power generation system. So we link this to the water fuel cell, and we're going to be releasing this unit, which will be the equivalent to half size of a hot water tank, about 18 inches in diameter, and its average power draw will be 220, 300 amp draw capacity. And link this up to the water fuel cell, then we have an unlimited power source, very economic. And the only thing I'm using here is a tube, a bunch of wires, and the gas. Now I would not point out how to make the magnetized gas for an extremely long period of time, because when a scientist comes into my laboratory and says, if you can show me how to stabilize the magnetized gas at room temperatures, you're doing something. And he's right, because this will set on an evolution like you will not believe. Now in chemistry, and linking up the atoms, we're always under a natural state in order to link up the atoms to covalent link up. Now there are a lot of ways of doing it. Now there's 3 atoms that exist in nature that exhibits electromagnetic fields. There are iron ions, and there are nickel ions, and there are cobalt ions. And the key to the link up was to come up with a gas lattice that would stabilize at room temperature and amplify the electromagnetic field. So one of the techniques, this is not the only technique, but this is the technique that I'll relate. But there will be an evolution now in chemistry where hundreds of millions of new chemical compounds will come about as a result of this. Under the prior state of the art, there are such atoms now in this particular case to make a magnetic gas lattice. We're using iron and iron ions and argon as an example. Iron, cobalt, and nickel are atoms. Now, they look at it as a metal substance, but really they're composed of the same atomic structure. They only have different number of protons and different number of electrons, right? All right, so if you get them down into the atomic structure, then they operate and function just like any other atoms do. And now, the reason why iron as an example, or cobalt or nickel, exhibits electromagnetic fields is because all of their electrons rotate in the same direction. The reason why the wood and so forth does not exhibit an electromagnetic field is because their electrons pair together and they rotate in opposite direction. Okay, and there has been examples of taking atoms and exposing them under plasma under real high temperatures and high pressures, and they would start to exhibit an electromagnetic field. But tremendous energy must go into that type of system to try to generate the magnetic field. So the key is, how do you stabilize it? Well, as we pointed out earlier, that when I took the combustible gas atoms, which we call the hydrogen gas gun, and we exposed that atom to a high voltage field, we got the ionization effect occur, right? Now in this particular case, I'm using iron and argon atoms to link up. Now traditionally, argon is an atom that doesn't link up to anything. It's chemically inert. Why is it chemically inert? And the reason why it's chemically inert is because its second electron orbit is composed of 8 electrons.
Complete octet.
Right, and as it has its 8 complete electrons, it doesn't want to covalently link up to anything. Well now, the question is how do you look at it to accomplish the problem? Well, if that has 8 electrons, why can I not now expose the argon atom to high voltage and pluck off its electrons? Can I not do that? Huh? Can I now inject laser energy into the process that aids the process of now aiding to knock off the electrons? In other words, if I had an atomic structure this way, then the electrons would go from that orbit to K, L, M, and N orbits, and then eventually be ejected off by the voltage. Can I not do that?
Yeah.
What proves that out? How about an argon laser? It does it. All right, so therefore, the point in the hydrogen gas gun technology, by the way, the hydrogen gas gun technology can be reduced down to the size of a spark plug or the fuel injection port of a F-18 or F-16. So you can miniaturize this thing down tremendously. Now in this technology, matter of fact, when you send laser energy into this process, not only could we generate the electrical energy for all the cities in New Zealand, but I can reduce it down to the size of an IC chip and replace the battery in electronics. Isn't that phenomenal? Okay, now, get back on this a minute. If I want to be able to covalently link up with atoms that normally do not link up, then can I not just simply pluck the outer electrons of that atom and now use it as a covalent link up? So if I pluck 4 electrons from here, from the argon atom, would it not now link up with the iron ions that also have missing electrons?
Which was not possible before.
Yes, and the reason why it wasn't possible before was the invention of the VIC circuit. The VIC unit restrict amp flow, right? Now like a neon tube. You take a high voltage a neon tube, it produced the light, it plucked off the electrons, right? And then when it was plucking off the electrons, it allowed electrons to go back in the process to stabilize it, to go ahead and pulse again at 60 cycles to release more energy, right? All right, on the VIC unit though, when you pluck the electrons, you're not allowing electrons to go back into the process. Now, so therefore, if I would now expose these two opposite gases, and I now set and inject laser energy in the process, and plucking off their electrons, if I pluck off their electrons, would they not covalently link up? Absolutely, they would have to link up. So now I have a gas lattice now, where it now can exhibit the electromagnetic field. So if I would have put the gas lattice now inside,
You're saying the gas lattice is argon and ion?
no, argon and iron ions or nickel or cobalt or any combination thereof. Okay, this is only one example.
Where do you get the ions from?
Well, if you have iron, can you not decompose an iron block into iron ions, and then made up of atomic structure of atoms?
Once you knock the electrons off, that's the whole thing, isn't it?
Right. The key was artificial knocking it off. As a result of this, hundreds of thousands of millions of new chemical compounds will come about. The prior art in chemistry is if you had atom A here and say, well, I need atom B down here, they may have had to put a whole string of other atoms to come down here to atom X, right? And the reason why they did that was because of covalent link up of the atoms, right? All right. Why can I not bypass the step and knock off the electrons here and knock off the electrons here and control it to such an extent that they have a match?
So you can get like quarter tones in the atomic structure instead of having the harmonic Pythagorean structure. You can vary that along in great further shades.
Right, absolutely.
Yeah.
You see that? Am I defining laws of physics?
It's like artificially produced isotopes.
Right. Or artificially simply well, isotopes, if you want to talk about isotopes, you're talking about putting more 2 or 3 electrons into the orbit and everything. What we're doing is plucking the electrons out. All right, we're plucking it out. I'm injecting laser energy in the process to simply aid the process. In other words, here's the atom, and I'm now injecting the laser energy. Right?
What sort of laser energy? Is it helium, neon, or argon, or?
Doesn't matter.
Doesn't matter, anything.
I mean, on certain atoms, it will take a different frequency of laser energy, but you simply tune in on the laser frequency of absorption, and so it does it. So basically, a photon light source works very well on it. If here are your energy orbits, and again, you're bouncing from K, L, M, and N. So if you subject this, you're knocking off the electrons. You're subjecting it to a tremendous high pulse voltage. I'm now plucking the electrons. I still have the laser energy here to keep it from going back to stable state. If I intermix those chemicals in the hydrogen fraction technology, they will covalently link up.
What sort of voltage do you need? Is it 10,000, 50,000?
Doesn't matter. Very little. How much? See, in kilos.
The high voltage plucking device.
Yeah. It doesn't, it can go from 2,000 volts to 10,000 volts, or take it to 20,000 volts up to 90,000 volts. It depends on what type of application that you want. The key was that we could produce hundreds of thousands and millions of cubic feet of magnetized gas in the garage by using the hydrogen fracturing technology or hydrogen gun technology to give us this ability. So now we're linking, unlike atoms that heretofore you could not link up naturally. We're artificially linking them up by plucking out their electrons. So when you expose the gas to an external magnetic field, then what happens is the magnetic field of this iron ion now starts to link up and you produce an electromagnetic flux line, like so.
Which is a composite of the whole lot.
Yes, right, all the way around the tube, all the way around the non-magnetic tube. Now the reason why I'm using argon in this case is that there's some characteristics to argon. The characteristics being is that argon is like a lubricator. Second thing is that it's an anti-static device. It doesn't like to transmit electrical energy in it. And it also has the ability that's a magnetic shunt. It doesn't like to be magnetized. And as a result of that, then when you expose it, you're now creating this electromagnetic field. Isn't that amazing? So not only are you're linking up the gas lattice by covalent link up, I'm also now linking it up by electromagnetic link up from one atom structure to another to produce the magnetic flux line. So it's quite obvious now that if I would now take this and I would expose it to the electromagnetic field moving through the pickup coil, would I not generate electrical energy?
By the way, Stan, you'll be making superconductors totally obsolete, won't you?
Yes.
Totally obsolete.
Yes. Yes. The superconductor is basically on trying to transmit electrical power without, least resistance on it. Okay, so that's the basic principle of why the EPG system works. Any questions?
I'm still confused about the ions. How you manufacture them?
Well, if you go back in the many years ago, 20, 30, 34 years ago, or in the 40s, 30s and the 40s, they were using ion generators to generate ions from many different metals, even including iron and cobalt and nickel. So,
Oh, you mean like an ion generator, a negative ion generator?
sure. And you take your metals and you decompose it into the atomic structure. There's a lot of ways of doing it, but there's too many hours to describe the apparatuses.
What makes it a magnetic gas? Why would it be magnetic, not?
Well, because I'm using atoms that all of their electrons spin in the same direction. So if you have an atom that all of its electrons spins in the same direction, it will exhibit an electromagnetic field equivalent to the number of electrons that are spinning under the electromagnetic theory of magnetism, that whenever an electric charged particle passes through an electrostatic field, its byproduct is electromagnetic energy.
But iron by itself
See?
is not permanently magnetized, is it? Steel is, but iron wouldn't be.
Yeah.
So why is iron not steel? Well, then the other way around. And why would that not be the same thing as the normal iron?
Well, say that again now.
Well, iron, soft iron, is not
Right.
magnetic in itself, is it? Not
Yeah.
permanently magnetized.
True.
But steel is.
Yeah.
So why is that? You've got iron there. Why is it not? Why would
Well, the reason why that would, well, as I said, now I'm giving you an example. And I said any combination thereof. You can take any combination of structures to do it. Now when you talk about creating the electromagnetic fields and you're coming up with the combinations, you can take the combinations and mix it and expose it in the same process. The reason for that strictly is why it's holding the magnetic field. It's because it's allowing the electromagnetic spin to not pair together. All right, so in this particular case, the argon atoms are all pairing together and they're spinning in opposite direction. But it will stabilize to allow these electrons to spin in the same direction. But you can take any combination of any of the ion structures and put them together to create and enhance the
So
electromagnetic
you
field.
could use neodymium iron boron, for example,
Sure.
which is a very, very strong magnet
Right,
material.
exactly the same thing.
And that's permanent.
Right.
It remain as permanent. You get permanent.
Right, right. You can use all the state-of-the-art
domains.
of what they're using today to enhance and stabilize that magnetic field. The real point being is that once you do this, you're not going to inject the laser energy and to amplify that electromagnetic field. So you're not restricted to just one. I'm giving this as an example of the approach. If I went to a more complicated, it may be a little bit more harder to understand. Okay, so that's the basis of the EPG system technology. Now, we also have some advanced technology which we're not bringing out at the present time, and that's also in the atomic reduction process. So this technology has led us to alter the state of the atoms, that we can reduce the structure of the atom downward and then covalently link it up with unlike atoms again. So it's opening the doors in areas of,
You can do anything literally with matter now.
yeah.
You
So
can
basically,
transmute.
transmutation is a fait accompli.
Well,
Well, to an extent.
well, yeah. Again, it's only subject to limitation, you know, to actually put it to work. So the real key is to communicate what we have done and why we're doing it, because we're going to be faced with a very critical worldwide problem, I feel. If the Mideast, as I pointed out earlier, erupts into war, then there's a possibility that oil is going to be contaminated. If it's contaminated, we better start moving in one accord. Otherwise, the economies of not only New Zealand and other countries are going to be destroyed very quickly. But we have a way of doing it, and the way that we must accomplish it is to sit down there and decentralize the production of the system and decentralize it in installation and set it up as an independent business entities. And that's the vehicle which the Lord has shown me to do it very successfully in the United States, and we are doing this at the present time.
Well, we're ready to do
That's
it.
it.
Is anybody else who would like to take the floor and add anything or
Or ask any questions, or,
anything?
oh, here, obviously, here.
Anybody at all, the floor is open for any questions.
What's your purpose for coming here?
Well, the Lord pulled me away from the project and said to go to New Zealand.
He knows now.
And,
You started to see.
so I started asking some questions, and I'm finding out that New Zealand's importing about 50% of their oil into this country. So you're much like we are. We import 60% of oil to maintain our economy. If that oil is cut off, tomorrow you die, and we die. So the area is to communicate. I've been going to many countries all over the world, communicating and talking about the technology, and to say, hey, there's an answer. Because what we're talking about today, if it complies with the law of economics, and it complies to the KISS method, keep it simple, stupid, and it gives us an answer to the energy problem, then put this technology in the wrong hands, like the mafia, or to the Arabs, or any other hostile foreign country. Then those countries that would be blocked with this technology would be destroyed economically very, very quickly. And those countries that would have access to this technology could be prospered very quickly. So it's paramount that, unfortunately, there are those who seek to destroy, and very few seek to build and to maintain. So I have imparted now all of this knowledge and wisdom, and now you have a great responsibility. As I had a responsibility in developing the technology under the Power and Authority Word of God and bringing it to this state, now I'm communicating to you. Now we can invent and develop this technology, show you that in fact we have an answered energy problem, but in the final equation, it's going to be coming down to you guys whether or not it's going to get in. So I don't know the laws in New Zealand. I don't know the people in New Zealand. I don't know their philosophy. I don't know the enemies against New Zealand. But I do know that as the time goes, you're going to have to need this answer, just like the other countries. And we've got to be able to somehow move in one accord to bring it about. And if we don't do it, don't rely on the government to do it, of any nation.
Absolutely.
And don't rely on any international corporations to do it, because they're not going to do it.
That's right.
It's going to come down to you and I and the guy down the street that says, hey, we're going to pick up the challenge and pick up the ball and go. And if we don't do it, well then the work has been
You're
in vain.
saying go ahead and do it? I mean, you've got patents on it. Are you looking for
Yeah,
sponsor or-
what I'm starting to do now is to start the vehicle capable of doing it. Now, if I can develop the technology or the equipment, we are now